Get out your calculators. Whether you have a TI-83 or a TI-84, it's going to be the same. Everyone go to the math menu. Everyone go to the math menu. Arrow down, what does 8 say? Okay, what do you mean? You're riveted. So math, 8. What we are going to do, now if you have an 84, yours looks different. Remind me how it looks. Oh yeah. Okay, so let me go through the 83 first. We are going to put our function in. Negative 1/2 plus 7/5 x squared. Okay. If you have an 83, you need to put a comma and say, I want you to take this with respect to x, and then comma, I want you to evaluate it at 0. If you have an 84, you just need to fill in that bottom box with x, so it is d dx. Type in your function, and then, because it looks like this, right? Like that. X needs to go here. You're going to type in your function here, and then this is where you put the number you want to evaluate it at. Yeah. Is it x cubed? Sorry, I read x squared.
I also got that.
Okay, so let's talk about that. What does that mean? 0.000000001. Your calculator is approximating, that rounds to 0. Okay. All right, so what was 34? What was the function for 84? Not 84, 34. What? We weren't?
No, we 35.
Then that's what I want.
Y equals everything 4x plus 1 squared.
So the quantity,
Yeah.
4x plus 1, the quantity squared, with respect to x, and where are we evaluating it at? 0? Okay. I'm teaching you this. Right now, you're just going to check your work with it. You can only evaluate at a point. You can't, like, find a general derivative. Like, if you put in x squared, it's not going to give you 2x. But if you put in derivative of x squared at 4, it'll give you 8. Okay? You can only find a derivative at a point. All right. Other questions about the homework? Yes.
45.
Okay, go ahead and write down f of x equals 6 minus x squared. One of the most important things that we've talked about in the past 2 days is tangent line equations. And so I want to make sure that we are rock stars at tangent line equations. If I ask you to write a tangent line equation, everybody, what's the first thing that we need? Very good. Everybody, what's the first thing that we need? The derivative. You see tangent line, your brain needs to think derivative. Okay? So the derivative of 6 minus x squared would be what, Henry? Negative 2x. So if we need a tangent line equation, what do we need to do with the derivative equals negative 2x? Trevor, what should we do?
Plug in 0 for x.
Why 0?
Oh, wait, no, 2.
Okay. We need to plug in 2 because that's what they're asking for, right? So that makes our derivative negative 4. Do we have all the information we need for our tangent line? Eric, what do we need?
You need to plug in the 2 to the original equation to get the coordinates.
Okay, we need the y coordinate, right? F of 2 would be, what do you know? 2. So then our tangent line equation could be y minus our y value of 2, slope of negative 4, x minus our x value of 2. Now, we jumped the gun a little bit with working on our calculator derivatives. This is not something that will be on the quiz tomorrow. I don't think you will get your calculator on the quiz tomorrow, but let's practice it so that we can use it to help check our answers throughout tonight's homework. Please find the derivative of 6 minus x squared at 2 to make sure that negative 4 was indeed our correct slope. Yep. So x is a variable. The value would be, in this case, 2. So you put 2 there. You want first derivative, so you're okay. And then you can type in your equation. Does that make sense? Yeah. Okay. Yeah, fancy. Yeah. Do we indeed get negative 4? Anybody having trouble getting negative 4? Starting in this unit, your tests will be 1 day calculator, 1 day non-calculator, because that is what the AP test is. 2 parts calculator, 2 parts non-calculator. So we really need to get comfortable using your calculator. Okay. All right. Let's talk about something from pre-calculus. No. I do love her. Okay, 2 words. Average rate of change. Okay, more than 2 words. 2 terms. Average rate of change, instantaneous rate of change. Take 30 seconds to talk to your neighbor and see if you can decipher between the 2.
Yeah. We started off really bad, but then it played together.
Okay, let's chat. Trevor, would you like to finish your thought aloud?
Well, instantaneous rate of change is where it's at, at that moment.
Where what is that? Or what specifically are we looking at?
The slope.
The slope. Instantaneous rate of change is the slope at 1 point, you said. Where average rate of change is what, Will?
The slope over the entire.
Okay, so not 1 point, but maybe. Okay, 2 points. We probably can't find slope of like 5 points, right? But between 2 points, that covers a lot of points. Is kind of what you're trying to say. All right. Average rate of change is the rate of change between 2 points. So if we are looking at x1 to x2, which Will was trying to describe, all of our points. If we talk about average rate of change, we just find the slope between those 2 points. Okay, I heard Pod 6 talking about like a velocity example. Okay, rate of change would be velocity and motion problems, right? So at this one instant, I'm going 200 miles an hour. That would be instantaneous rate of change. While average rate of change, okay, I traveled this distance in this many hours. Our average rate was, whatever miles per hour, okay? We made an average of $100 per year, because this is where we started. This is where we ended. Here's the average. Okay. Versus, you already know this, that the instantaneous rate of change is going to be the slope at 1 point. Okay. I am going 50 miles per hour at this one very instant. So it is important that you understand the difference between average rate of change and instantaneous rate of change, and what that means as far as the math that we need to do to find it. Next semester, I'll even introduce you to something called average value, which is different in and of itself, so we kind of have to keep all of them straight. What's the difference between them and how do we mathematically solve them? Okay? So I would like you to, we're going to go back to 6 minus x squared. That is still going to be our function. And what I would like us to do is find the average rate of change for over the interval 2 to 5. Okay, so if we're going to find the average rate of change, what pieces of information do we need? We need 2 points, so we can find the slope, right? Well, we have x is 2 and x is 5. We need the y coordinate so we can find slope, change in y over change in x. So, f of 2, we already found that to be 2, didn't we? On the previous slide. F of 5. Negative 19. Okay, so our average rate of change is going to be y minus y over x minus x. What's our average rate of change here? Instantaneous rate of change at x equals negative 2. CJ, what would that be?
4.
And how'd you get that?
Plug negative 2 into the derivative.
So the derivative we found earlier was negative 2x. If we plug in negative 2, we get an instantaneous rate of change. All right, who are my physics people in the room? You have taken physics or you are taking physics, 1 or 2. Okay. Do you do any sort of motion in physical science? Yes? Okay. So a lot of this should be familiar to most of you, if not all of you. Okay? We're going to talk about some motion problems here. This is kind of the intro, and then our last unit of the class is going to be a motion unit where we talk about position, velocity, and acceleration and how they relate to each other, and how to use calculus with it. Okay, but here's just a little taste. Okay, go ahead and write this down. First of all, this is a free falling object, so there is no projecting. It's just like something that's dropping or thrown straight up in the air and then dropping down. Yes.
When we do motion, are we gonna be able to do
Both. Which is why I have things with G's and B's in here. Okay. Sorry, I know it bothers everybody. Okay. What does G stand for? Okay. T stands for time, always in seconds. Okay, time is going to be in seconds. V naught, initial velocity, and S naught is initial position, where S is our position. Okay. Now, go ahead and write down our velocity equation. Notice how we have some familiar letters in there. Can you tell me what the relationship between S and T would be? Eric is asking, is the velocity the derivative of position? Yeah, it is. That's cool, right? Yeah. Okay. They are derivatives of, or the velocity is a derivative of position. It's the instantaneous rate of change of the position, right? Velocity is a rate of change. We talked about the derivative of position. We're talking about the instant distance is changing over time. Okay. Now, let's talk about gravity. Gravity is negative 32 feet per second squared if we're talking about feet, which some of you are like, you know, kind of not comfortable with, I guess you could say. What about in meters per second squared? So if you are given something in feet, you need the negative 32, but if you're given something in meters, you will need the negative 90. All right, so a physics book is thrown straight down. Here, a physics book is thrown straight down. Someone's angry. From the top of a 220-foot building with an initial velocity of 26 feet per second. I will never tell Mr. Marsh this, but has anybody ever just wanted to chuck their physics book? Okay. They're pretty heavy. They are pretty heavy. Okay. I like physics, but. Okay, so let's pick out our key information. What's important? Okay, so we're at a 220-foot building. that is probably our initial position. That's an S. Something's weird with my smartboard. What else? 26 feet per second is V naught. And is that what you're going to point out? Okay. And since we're just throwing something straight down, we know it's free fall motion. Okay. Write the position equation. All right. So 1/2 times gravity would be -16. We are throwing our book down, which means what about the velocity? Well, what about its direction, Susan? Okay, since we're throwing the book down, our velocity needs to be negative because that's the direction of our velocity. And then we have an initial height of 220 feet. Okay. The instantaneous velocity equation. Now, I gave you how to set it up. I wouldn't even worry about that. If you have position, you should be able to get velocity just by looking at the derivative. Okay? So what's the derivative of -16t squared? -32t. -26t. -26. And then the derivative of 220, it's a constant, so 0. Okay. All right. How long does it take the book to reach the ground? Think about it, process it. How long does it take the book to reach the ground? First question. What variable are we solving for? T. It says how long, we're solving for T. Does it take the book to reach the ground? Which equation do we need to look at, position or velocity? Position, and specifically we're looking for when position is what? Okay. You have a quadratic that equals 0. You made that face because? You don't like quadratics, okay? What are we going to need to use? We need to use the quadratic formula. I will give you a minute to determine the two values where t is 0. There is a program, I think, but I don't know.
It's under ALS, it's called
You should be getting 2 answers. Okay, what is one of the answers? Negative 4 point what?
6.
Okay, what's the other one? 2.984. Remember, I want 3 decimal places. Okay. Now, negative 4.6. Can we have negative time?
No.
No, but graphically we have negative t values in a quadratic. That just happens. Okay. So 2.984 seconds is how long it will take your physics book to reach the ground and probably break into at least 2 months. When did you expect your physics book to kind of get destroyed from that? I feel like it'll come. Okay. What will the velocity be of the book when it reaches the ground? Now, what equation do we need to work with? Velocity. We are looking for velocity. What t value do we need to plug in? 2.984. So we're looking for the velocity at 2.984. Now, for some of you, you might want to use your fancy schmancy calculator to just recall that answer instead of having to type it in, right? You know that you can either arrow up to recall it or second answer if it was the last thing that you had. Okay. What is our velocity? Say it.
Negative 121.48.
And your label would be feet per second. Because we're talking about feet, our height of feet changing over time seconds. Okay. Do not worry tomorrow about remembering the 2 different gravities because I'll already have that in for you. Okay, if that helps. But this is what you need to think about for the quiz. Don't write these down, please, because what I'll have you do is get out your gold sheets and evaluate yourself on the objectives. Okay? But on the quiz tomorrow, you will have to use the definition of a derivative, aka the limit of the difference quotient. You're going to have to do that. But guess what? You know what the answer should be. Just make sure your work matches the answer that you know it should be. Power rule. Make sure you can do power rule with basic and ones that you have to rewrite. Write the equation of a tangent line. Like we did for our warm-up, find points of horizontal tangency. Average rate of change versus instantaneous rate of change. There's where your homework's going to be important. Derivatives or functions and their graphs. Derivative, I'm not saying the right words in the right order. Okay, functions and their derivatives and how they relate graphically. There we go. And then these velocity and position. Okay, basically you kind of just need to get comfortable with the relationship of position to velocity being the derivative and answering the questions that are being asked. Okay, so we still have a few minutes left in class. What I would like you to do is get out your gold sheets. On the back of your gold sheet, you have those lists of objectives. Tomorrow's quiz is over 2-1 and 2-2. Go ahead and rate yourself about how you feel. Reflect on what extra practice you need to do besides the homework I have assigned for tonight. And then you can go ahead and get started because we have 5 minutes in class. Okay? You can do a problem or two.